Hello friends, welcome you all to the next lecture of the JC eConnect series of online lectures. We are into module 4 and in this module we are studying about centroid. In previous classes we have finished deriving the relationships for various geometrical figures to obtain their centroid. Now it's a time to apply those formula and solve examples. So I have simplified the steps following which we can easily solve the examples. Before this, I want to stretch on an important fact that this module is very critical from exam point of view, as the questions in this module are straightforward. Out of those 4 or 5 derivations, one derivation is but sure in maximum of the papers we have found it. Secondly, the sums also which come are straightforward. Then the most important thing is, in this module the sums which are there can be solved stepwise. There is nothing up down or resolution of force and those all things. Hence these problems are easy if you practice them. So module 4, that is centroid and moment of inertia, is very important with respect to the exam. So I request you all to concentrate properly on these sums and solve the sums daily so that you can keep the things up to date. Then for civil and mechanical engineers, this topic is of utmost importance, because in your further semesters also you will have application of this chapter. So let's start with the step for solving the problems on centroid. I have divided the procedure into 4 steps. Step 1. Analyze the figure. Locate the axis about which centroid has to be obtained if it is not given. Else, consider the given axis. The step means that firstly we have to analyze the figure. We have to check whether the figure is symmetrical about any axis. Then we have to locate the centroidal axis. We have to locate the reference axis about which we got to obtain the centroid. If in the given problem or in the given example, if the reference axis is mentioned, we need not take our own axis. If the reference axis is not mentioned, we should go for our reference axis. Now once we go to the further examples, these things will be clear. Then next, second step, we have to divide the given figure into number of elemental areas of well-defined shape and obtain the area of each element. Now for example, if I have a T section, letter alphabet T. T section can be divided into 2 rectangles, one horizontal rectangle and one vertical rectangle. That's what I mean here by dividing the figure into number of elemental areas of well-defined shape. Say for example, if I have a letter I for India, this I letter can be divided into how many subfigures? 3. Yes, we can divide the letter I into 2 horizontal rectangles and 1 vertical rectangles. That's what I mean in this step. Then in the third step, we have to find the distance of each elemental figure with respect to the axis, the centroidal distance of each elemental figure with respect to the reference axis which we have taken. So now if we have 2 elemental figures, we have to find x1, y1, x2, y2. If we have 3 elemental figures, we have to obtain x1, x2, x3 and y1, y2, y3. This step becomes very much important because all the things will depend on this particular step. Then in the last step, we have to just take the summations to find the coordinates of our centroid. That is, we obtain x bar by taking summation of ax upon a, where summation of ax means a1 x1 plus a2 x2 plus a3 x3 and so on, and divided by a is the summation of all the elemental areas, that is a1 plus a2 plus a3. Similarly, y bar is summation of ay upon a, where summation ay is what? a1 y1 plus a2 into y2 plus a2 a3 into y3 and so on, divided by capital A, which is the summation of all the elemental areas, that is a1 plus a2 plus a3 and so on. So now it depends on how many elements we are dividing our figure into. Generally, with respect to the examples, maximum will be 4. Okay, it's very rare that in example we have to find or we have to take 5 elemental areas. So maximum areas which we deal with at a time is 4, minimum will be 2. Okay, so these are the 4 steps which have to be followed for obtaining solution. So first step, analyze the figure, locate the axis if not given. Second step, divide your figure into well-defined elemental areas and find the areas. Third step, obtain the centroidal distance of each elemental area with respect to the reference axis. And in the last step, obtain the coordinates of the centroid using the simple formula. Hopefully you have understood, but you will get a better picture once we solve some examples. But remember, these are the 4 key steps which you need to follow to solve the examples. Now, some key points which you have to remember. Now this I have put it by my experience, where particularly students make a mistake. Okay, I have tried to cover such points which I have mentioned them as key points. Okay, so let's discuss the key points. Firstly, draw the figure neat, clean and of sufficient size. I always tell you all in the class, don't draw stamp size figures. Okay, draw a suitable big figure so that all the required markings can be done properly. Prefer to start a new example on a fresh page, because here we have to refer the figure while solving for taking the distances, and if you have to turn the page, it sometimes becomes tricky and difficult, or you might miss some value or misinterpret some value. The next, identify the symmetry, if any, about which axis? About probable centroidal axis. Now if I give you the example of letter T, if we cut the letter T vertically, okay, if we are cutting the letter T vertically, the left and right will be the same. That means the letter T, T for tiger, letter T is symmetrical about which axis? Vertical centroidal axis. Now in such case, the horizontal component of the centroid, that is x bar, can be directly found. Okay, so this thing you have to remember. You have to identify the figure or identify the symmetry in the figure. Now if similarly, if the element is symmetrical about horizontal axis, okay, say if this figure is symmetrical about horizontal axis or symmetrical about x axis, y bar can be obtained directly. So no need of calculation for these things in case of symmetrical objects. Now in one question paper, the centroidal axis itself was marked and it was only given as the reference axis. Okay, one such example I will try to cover in the subsequent lectures. Now in such case, if the centroidal axis itself is your reference axis and say the figure is symmetrical, then along the direction it is symmetrical, the other component becomes 0. That is, now for if you are taking a T section as example, and if your centroidal axis, that is the axis passing through the center of the figure itself, is your reference axis. Okay, it divides the figure exactly into two parts about left side and right side. So that means what? It is symmetrical about vertical axis. Hence x bar we can directly obtain. And where will x bar lie? On that axis itself. So in such cases x bar becomes 0. So one point you note down and remember, if your centroidal axis is itself your reference axis, then you need to be careful while obtaining x bar or y bar in the direction of symmetry. Maximum times it is not asked, but rarely in one question paper I had found one example in which this was asked. Then third point to be taken care of is all the centroidal distances of all the elements should be located with reference to the selected reference axis only. Okay, you have to locate x1, x2, y1, y2, etc. with respect to the selected reference axis only. Okay, so this point many times it becomes a point of confusion when we are solving examples. In further lectures, this point again I will highlight there. As of now, you note it down. Then complete the calculations figure wise to avoid confusion. What do I mean by this? Now if I am analyzing a I section will have three elemental figures, right? So solve the things element wise, that is a1, x1, y1, a2, x2, y2, a3, x3, y3, because that reduces confusion and makes the solving process easy. Next point is, if the reference axis is not given, okay, select the reference axis such that the entire figure lies in the first quadrant. Okay, that is our standard axis. Okay, where x is also positive, y is also positive. In all cases it may not be possible, but if we have the opportunity, it's always better to take the reference axis such that the element lies in the first quadrant. Next, if the axis of reference are such that the entire figure does not lie in the same quadrant, then be careful about the positive and negative signs to be taken. That means now in first quadrant both x and y will be positive, but if you go to second quadrant, what happens? X becomes negative whereas y remains positive only. Whereas in third quadrant, what can happen? X becomes negative as well as y is also negative. And now if your figure is in which quadrant? Fourth quadrant, there x will be positive and y will be negative. So it's not difficult, just you have to follow the basic quadrant rule. I have selected some examples where some part of the figure goes in second quadrant. Okay, so that time we can understand this point, but as of now, note it down and remember it properly. So we have discussed the 4 steps which will make our problem solving process easy, and then some 6 key points I have discussed which are very much essential for smooth process of solving. So I request you all to note down these points and make proper notes of it, so that in the next lecture when we start with the examples, connecting these points with the examples becomes easy. Hope all of you are taking proper care, all of you are fit, fine and healthy. Hopefully this all things will get over early, and hope to see you back in the classrooms at the earliest. Thank you.